Your EV battery dies in winter. This one barely notices minus 30 degrees Celsius and keeps almost all its power. Heat it past 100 degrees Celsius, still fine. Charge it in 5 minutes. Use it every day for a century. And it might not even use lithium. Yes, you heard right. That's not an upgrade. That's either a technological miracle or the boldest bluff in EV history. Donut Labs' solid-state battery claims sound less like a product launch and more like someone rewriting the laws of energy storage. Because normally batteries are all about trade-offs. Do you want fast charging? Then you'd sacrifice lifespan. Do you want high energy density? Heat becomes a nightmare. You want durability? Weight goes up. Engineers spend decades juggling these compromises. Donut Lab is basically saying, we solved all of them at once. Start with temperature, the silent killer of electric vehicles. In extreme colds, lithium-ion batteries slow down chemically. Ion movement becomes sluggish, internal resistance spikes, and suddenly your shiny EV feels like it aged 20 years overnight. Losing 30 to 50% of usable range in brutal winter conditions is completely normal. Owners in cold regions plan their lives around it. Donut Lab says their battery keeps more than 99% of its capacity at minus 30 degrees Celsius. Not usable. Not reduced. Almost everything. That alone would transform EV ownership in places with real winters. No preheating rituals, no panic when the temperature drops, just drive. Now flip the scenario. Heat and high temperatures are just as destructive, sometimes worse. Conventional batteries degrade, generate gas, warp internally, and in extreme cases enter thermal runaway, which is a polite engineering term for, this thing is on fire and you don't want to be nearby. Yet Donut Lab claims the same stability above 100 degrees Celsius. That's boiling water territory. Most batteries don't just struggle there, they fail catastrophically. So cold doesn't cripple it. Heat doesn't destabilize it. If accurate, that means this battery could operate almost anywhere on Earth without special thermal babysitting systems. Arctic roads, desert highways, industrial environments, everything. But temperature resilience is just the opening act. The headline feature, the one that makes people lean forward, is charging speed. 5 minutes. 0 to full. About as long as it takes to pay for fuel and grab a snack. If that becomes real at scale, charging stops stop being a thing. Road trips have become normal again. Fleet vehicles stay on the road instead of parked at chargers. Apartment dwellers without home charging suddenly have a practical solution. The psychological barrier to EV adoption collapses overnight. And here's the twist. Fast charging usually destroys batteries. High current generates heat and structural stress, accelerating degradation. That's why today's EVs slow charging dramatically near full capacity to protect themselves. Donut Lab says their battery can charge insanely fast and still survive around 10,000 full cycles. To understand how wild that is, most premium EV batteries today are rated somewhere around 1,500 to 2,000 cycles. That's already enough for hundreds of thousands of kilometers. 10,000 cycles pushes the lifespan into generational territory. Charge daily and you're talking decades upon decades of use. Some estimates stretch toward a century. Imagine buying a vehicle and never worrying about battery replacement for your entire lifetime. Now add energy density to the pile. The company reports roughly 400 watt-hours per kilogram. Most mass-produced EV batteries sit far lower than that. Higher density means either longer range for the same weight or lighter vehicles for the same range. A car that currently travels 300 miles could potentially push towards 600 without adding mass. Motorcycles become lighter and faster. Aircraft electrification starts looking less ridiculous. Even portable devices would change dramatically. Individually, each of these claims would be big news. Together, they sound almost physically impossible. Because in conventional electrochemistry, these performance metrics fight each other. Improving one usually harms another. That's why experts immediately started asking, what exactly is different here? Donut Lab hints that the answer lies in a fundamentally different way of storing energy. Traditional lithium-ion batteries rely on intercalation, ions squeezing into rigid crystal structures. It's slow, stressful, and eventually damaging, like repeatedly forcing books into an overstuffed shelf. Over time, cracks form, materials degrade, performance drops. Many engineers suspect Donut Lab's design leans heavily on something called pseudo-capacitance. In simpler terms, instead of forcing ions deep into solid materials, energy is stored through rapid surface reactions. Think of it as placing books on a table instead of cramming them into shelves. It's faster, gentler, and far less destructive. Combine that with nanostructured materials offering enormous surface area, and suddenly you can store a lot of energy very quickly without tearing the material apart. The solid-state aspect matters too. Removing liquid electrolytes eliminates one of the biggest sources of instability and fire risk. Solid materials don't leak, boil, or produce flammable vapor in the same way. That's why solid-state batteries have been considered the holy grail for years. Safer, denser, longer lasting, at least in theory. But theory and mass production are two very different worlds. And this is where skepticism enters the room. Because as impressive as the claims are, independent verification is still limited. No widely available peer-reviewed studies, no public third-party test data. Most information comes directly from the company itself. In an industry with a long history of revolutionary batteries that never left the lab, caution is natural. Scaling is notoriously brutal. It's one thing to make a tiny prototype perform beautifully. It's another to manufacture millions of large cells with consistent quality, durability, and cost efficiency. Tiny defects become big problems at scale. Yield issues can destroy profitability. Entire startups have collapsed at this stage. Another eyebrow-raising detail is the chemistry secrecy. The CEO has confirmed one thing: the battery does not rely on lithium. That alone stunned experts. Lithium dominates modern batteries because it offers high voltage and excellent energy density. Remove it, and achieving top-tier performance becomes extremely difficult. Yet Donut Lab insists they've done exactly that. Some speculation points toward advanced ceramic or amorphous materials, possibly titanium-based nanostructures, capable of supporting pseudo-capacitive behavior. These materials don't have rigid crystal lattices that crack under stress. They're more flexible at the microscopic level, which could explain extraordinary cycle life and rapid charging. But without disclosure, this remains educated guesswork. And here's a question that keeps coming up. If this battery is truly world-changing, why debut it in electric motorcycles instead of cars? Motorcycles require smaller battery packs, making them easier test platforms. That explanation makes sense. But skeptics argue that a breakthrough capable of transforming transportation would attract massive immediate adoption across industries. Limiting it to a niche segment raises suspicion, or at least curiosity. According to the company, real vehicles using these batteries could appear on public roads very soon, integrated into high-performance electric bikes. That rollout will be the ultimate reality check. You can't fake thousands of users charging daily in real weather conditions. Data will emerge quickly: range, degradation, safety, reliability. If performance holds, doubts will evaporate fast. If not, this will join the long list of overhyped technologies that couldn't survive outside controlled environments. Alright, back to the battery that may or may not rewrite the rulebook. One of the strangest aspects of this story is how the broader industry has responded, or rather, hasn't. Major automakers and battery giants have poured tens of billions into solid-state research for over a decade, moving cautiously due to immense technical challenges. The idea that a small startup could leapfrog everyone without triggering an acquisition frenzy feels unusual. Not impossible, just unusual. Then there's the manufacturing claim. Donut Lab suggests their material can be produced in a relatively straightforward way, almost like shaping a clay-like substance. If accurate, that could dramatically reduce production complexity compared to traditional battery assembly, which involves ultra-precise layering and strict environmental control. But again, scaling unknown materials is rarely simple in practice. Another point fueling debate is the lack of dramatic public demonstrations. In engineering culture, seeing a device operate under load, charging, discharging, heating, cooling, carries far more weight than slides or interviews. That absence keeps skepticism alive. Still, the company insists that independent verification is underway behind closed doors with industry partners under strict confidentiality agreements. If true, public confirmation may simply be delayed rather than non-existent. So why does all this matter beyond electric vehicles? Energy storage underpins modern civilization, improve batteries dramatically, and everything changes. Renewable energy becomes easier to store and distribute. Power grids become more resilient. Remote communities gain reliable electricity. Electric aviation becomes plausible. Even everyday gadgets transform. Phones that charge in minutes, laptops that last for days, devices that don't degrade after a few years. In other words, this isn't just about cars. It's about the infrastructure of the future. But history urges caution. Battery breakthroughs are announced constantly, yet only a few ever reshape the market. The real test isn't a press release. Thousands of cycles, years of use, manufacturing data, failure rates, safety records. Those are the metrics that separate genuine revolutions from hopeful prototypes. Right now, Donut Lab stands at a fascinating crossroads. The underlying scientific concepts, solid electrolytes, nanostructured materials, pseudo-capacitive storage, are legitimate and actively researched worldwide. Nothing about them is fantasy. What's extraordinary is the claim that all their benefits have been achieved simultaneously in a commercially viable product. If they're right, EVs could become cheaper, lighter, safer, longer-lasting, and dramatically more convenient almost overnight. Charging anxiety disappears. Battery replacement fears disappear. The biggest obstacles to electrification collapse. If they're wrong, or even partially wrong, the technology may still be impressive, just not miraculous. Either way, the next few years will reveal the truth. Real users, real roads, real data. Batteries don't care about hype. They perform, or they don't. So is Donut Labs' solid-state battery a historic leap forward or another story that sounds too good to be true? Honestly, we're watching the answer unfold in real time. And that uncertainty is what makes this moment so interesting. If the claims hold, future generations may look back at this period as the turning point when electric mobility stopped being an alternative and became the obvious choice. If not, it will still push the industry to innovate faster. Either outcome moves technology forward. What do you think? Breakthrough of the decade or overhyped science experiment? Drop your thoughts in the comments, I read them all. Subscribe and turn on notifications. The future isn't coming, it's already being tested.